In our previous lesson, we identified the amplitude and the period of a given sine function. In today's lesson, we will graph a sine function. Before starting our graph, let's get introduced to the parent function. The parent function is y equals sine x. Keep in mind that x could be in radians or in degrees. Let's start graphing the parent function because all the other functions will be a transformation or will be graphed based on the transformations of this parent function. Let's first find the period and the amplitude of the parent function. The period, as we know, is, since x is given in degrees, the period is 360 degrees divided by 1 since b is equal to 1. Then the period is 360 degrees. The amplitude is the absolute value of A, and here A is 1, then the amplitude is equal to 1. We will verify those values later on graphically. First, whenever you want to graph any sine function, we have to graph it based on a table of values. Our period here ranges from 0 to 360, so we are going to our x values are going to be between 0 and 360 degrees. Then we will divide the 360 degrees into 4. We will get 90. And then we will add another 90, 180 degrees, then another 90 to 170 degrees. Using your calculators, you can identify that the sine of 0 degrees is 0, the sine of 90 degrees is 1, the sine of 180 degrees is 0, 270 minus 1, the sine, and 360 has a sine of 0. This table of values is fixed, so you have to memorize it very well because you're going to use it in graphing every single sine function when x is in degrees. We will graph now y equals sine x using the table of values. We have 0. I'm going to take each 3 squares as 90 to have a clear graph. Then another 3 squares, 180 degrees, another 3 squares for 270 degrees, and then another 3 squares for 360 degrees. As you can see here that your y values have a maximum of 1 and a minimum of -1. So on the graph, I'm gonna write 1. I'm gonna take 4 squares for 1 and 4 squares downward for -1, again to have a clear graph. Now we start plotting our points. 0, 0. 90 has a y value of 1. 180 has a y value of 0. 270 has a y value of -1. 360 has a y value of 0. Now we need to connect the dots or the points in order to get our sine function, our parent sine function. As you can see, your sine function starts from 0 to 91, then 180, 0, then 270 with -1, and 360 with 0. We initially found that the period is 360 degrees, which is correct because this cycle starts from 0 and ends at 360. The amplitude is 1, which is correct because the maximum value is 1, minimum is -1. 1 minus -1 divided by 2 will give us an answer of 1. Now let's graph the parent function again, but this time x is in radians. When x is in radians, the period is 2 pi divided by b, and b is 1, then the period is 2 pi. And the amplitude is the absolute value of a is 1, and the amplitude is 1. Let's start with filling the table of values. So our table of values ranges from 0 to 2 pi. We divide 2 pi by 4 to get the other 4 values. 2 pi divided by 4 is pi over 2. Then we move by pi over 2. Then we add another pi over 2 to get pi. And then another pi over 2 will give us a value of 3 pi over 2. Sine of 0 is 0, sine of pi over 2 is 1, sine of pi is 0, 3 pi over 2 has a sign of -1, and 2 pi has a sign of 0. The table of values is ready in radian measures, and now we can plot the points on the graph. We divide the graph, each 3 units on the x-axis, one value, and that's a pi over 2. Then other 3 squares, we will have pi, 3 more squares, 3 pi over 2, 3 more squares to reach 2 pi. On your y-axis, you have a value of 1 as a maximum and -1 as a minimum. I'm going to take 4 squares for 1 and 4 squares downward for -1. Now we can plot our points. 0, 0 at the origin, pi over 2 with 1 as y value, pi has a y value of 0, 3 pi over 2, -1, and 2 pi. We have to connect the points to get our parent function sine x using radian measures. As you can see, the cycle ranges from 0 to 2 pi, and there is a maximum value of 1 and a minimum value of -1, which will give us an amplitude of 1. We are going to graph one cycle of y equals 2 sine x. As you can see here, the sine x is multiplied by 2, and that's a vertical dilation by a factor of 2. And remember that transformations were covered at the beginning of the year. Before we start graphing, I told you we need to start from the parent function, the table of values of the parent function. The parent function has 0, 90, 180, 270, 360 as x values, 0, 1, 0, -1, and 0 as y values. The table of values for the parent function will never change, and you're always going to refer to it and use it. The vertical dilation here by 2 is only going to change the y values of the parent function. So only the y values are going to change, and we're going to multiply them by 2, by the dilation factor. Only the y values are going to be multiplied by 2 to get the table of values of y equals 2 sine x. The x values are not going to change. 0, 90, 180, 270, 360. The only change is in the y values. 0 times 2 is a 0, 1 times 2 is a 2, 0, -2, and 0. Now this table will be used in order to graph y equals 2 sine x. We will graph our points. Remember, we are going to take 3 squares on the x-axis as 90, and then 180, 270, and 360 every 3 squares. On the y-axis, I'm going to take here each 4 as 1. This means to reach a value of 2, I need to take 8 squares. Remember, you can take whatever scale you find suitable as long as your graph shows clearly all the points in a sine function. So we have 0, 0, then we have 90, then 180, 270, and finally 360. On the y-axis, each 4 units as 1, so 8 units up for 2 and 8 units down for -2. Now we start plotting our points. We have 0, 0, 90 with 2, 180, 0, 270, -2, and 360, 0. Now we need to connect the points to show the graph of y equals 2 sine x. As you can see here, that the y equals 2 sine x is stretched by a scale factor of 2, and the period is 360 because the cycle starts at 0 and ends at 360 degrees. Amplitude is 2 because the maximum is 2 and the minimum is minus 2. Y equals 1.5 sine x, but this time x is in radians. 1.5, so we have a vertical stretch by a value of 1.5. Let's first of all, as we agreed, write down the table of the parent function y equals sine x, but this time in radians. The values of x start as 0, pi over 2, pi, 3 pi over 2, and finally 2 pi. Y values are fixed for the parent function: 0, 1, 0, minus 1, 0. As we said, we have a vertical dilation by a factor of 1.5. The vertical dilation changes the y values only. So we're going to multiply the y values by 1.5. We will complete now the table of values for y equals 1.5 sine x. We agreed that the x values will not change: 0, pi over 2, pi, 3 pi over 2, and 2 pi. The y values will be changed into 0, 1.5, 0, minus 1.5, and 0. We will use the table of values to graph y equals 1.5 sine x. On the x-axis, each 3 squares as a pi over 2. So we have pi over 2, and of course we don't forget at the origin 0, then pi, 3 pi over 2, and finally 2 pi. On the y-axis, I'm gonna choose as well each 4 squares as 1, so I need 6 squares for 1.5. Let's plot our points. 0, 0. For pi over 2, it's 1.5. 0 for pi. Negative 1.5 for 3 pi over 2. And 0 for 2 pi. Now we need to connect those points to get our graph. As you can see, the maximum value is 1.5, minimum is minus 1.5. There is obviously a vertical stretch by a factor of 1.5. The cycle ranges from 0 to 2 pi, giving a period of 2 pi. A new sine function, y equals minus 0.5 sine x. If you notice here, not only do we have a vertical dilation, which is a compression by a factor of 0.5, but also we have a reflection due to the negative sign here. Both reflection across x-axis and the vertical dilation change the y value only, no change in the x value. Keep in mind, reflection on x-axis and vertical dilation change the y values of the parent function sine x. We drew the table of sine x and we're gonna complete it using degree measures. Now, to construct the table of values for negative 0.5 sine x, the x values, they stay the same. What changes is the y values by multiplying them with negative 0.5. So the y values must be multiplied by negative 0.5 each. Then the y values of the new table would be 0, minus 0.5, 0, plus 0.5, and a 0. As you can see here, the reflection is clearly shown since 90 here in the parent function had a y value of 1, the positive goes up to the maximum, but in y equals negative 0.5 sine x, 90 goes to a minimum. This clearly shows a reflection across x-axis. To graph, we're going to take a scale, each of 3 squares as a 90 degrees on the x-axis. On the y-axis, I'm going to take each 4 squares as a unit. This means every 2 squares are going to represent 0.5. Kindly do not stick to the scale that I chose. You can choose every 4 squares as 90, as long as equal number of squares is taken between each value. Now let's plot our points. We will start with 0, 0, then the 90 goes to the negative 0.5, a minimum, 180 to 0, 270 to 0.5, 360, 0. We connect the points to get our graph. As you can see, it clearly shows a reflection across the x-axis and a compression by 0.5. Now the period is 360 because the cycle ranges from 0 to 360. The amplitude is 0.5 because the maximum is 0.5 and the minimum is minus 0.5.